Hello students, welcome to UMATHS class. I hope you all are eager to learn new concept with me. All of us know what a number line is, and the numbers we see here on the number line are integers. Positive integers are represented at the right of the zero and negative integers are represented at the left of the zero. Integers we are familiar with, but what about numbers like these? 1 by 3, 5 by 6 or minus 7 by 12. Each of these are numbers, but we don't use them as often as we use counting numbers. Such numbers are called rational numbers. But we need to define them well, right? We cannot say numbers like these are rational numbers. So we say that they are of the form p by q. One number in the numerator and one in the denominator. But there are few conditions we need to know. P and Q should be integers. We can have only integers in place of P and Q. And there is another important condition, Q should not be equal to 0. Why do you have this second condition? Think. Yes, I asked you to calculate 3 divided by 0. What would be the quotient? 0 multiplied by what will give you 3? There is no such number. Right students? This value is undefined. So this is the basic definition of rational number. It is a number of the form p by q where p and q are integers and q is not equal to 0. Now let us understand how do we represent rational numbers on a number line. To understand better, we will classify examples into two types. One in which numerator is less than denominator and the other in which numerator is greater than the denominator. Note here we are using only numerical values in the place of numerator and denominator. For example, if you are plotting minus 9 by 5, we will take 9 as a numerical value, not minus 9. We compare 9 and 5, not minus 9 and 5. So, minus 9 by 5 comes under numerator greater than denominator. Note here we will consider only numerical value in the numerator and denominator, not the sign. Let us look at first category, two examples. One of the categories of plotting the rational numbers on the number line is when the numerators are less than the denominators. Let us try to plot 1 by 2 and minus 1 by 2 on the number line. First we see how we can plot 1 by 2. The numerator 1 is less than the denominator 2. When the numerator is less than the denominator, the positive rational numbers will be between 0 and 1. So the number 1 by 2 has to lie somewhere between 0 and 1. Now we divide the length between 0 and 1 into equal parts. How many equal parts is the question, right? The denominator tells us the number of equal parts. The denominator is 2, so we divide it into 2 equal parts. This line divides this region into 2 equal parts. But what does the numerator tells us? It tells us the number of parts from 0. The numerator is 1 and therefore we take one part from 0 and mark 1 by 2 here. We can use the same procedure to mark minus 1 by 2 on the left side of 0. Divide it into 2 equal parts and mark minus 1 by 2 one part away from 0. Just as integer has corresponding values, rational number too have corresponding values. In our example, minus 1 by 2 corresponds to 1 by 2. Let us look at another example where the numerator is less than the denominator. We have to plot 3 by 4 and minus 3 by 4. Let us plot 3 by 4 first. Since the numerator is less than the denominator, we know that the number will be between 0 and 1. So we draw the numerator line like this. Remember, the denominator tells us number of equal parts. Since the denominator is 4, we divide the length between 0 and 1 into 4 equal parts. Now we move to the numerator. What the numerator tells us? The numerator tells us the number of parts from the number 0. The numerator is 3. We move 3 equal parts from 0. 1, 2, 3. So we mark 3 by 4 here. Now let us plot minus 3 by 4. Since 3 is less than 4 and the rational number is negative, we know that it will come between 0 and minus 1. We divide this length into 4 equal parts as the denominator is 4. And we mark minus 3 by 4 3 parts away from 0. Right, students? We have plotted the points, right? Let me ask you a question. You have plotted the numbers 3 by 4 and minus 3 by 4, right? But do you know which numbers are plotted on these points? Think. Yes, here is your answer. Since this is one part, we mark 1 by 4, and since this is two parts, we mark 2 by 4. Similarly, we can plot minus 1 by 4 and minus 2 by 4 here. It is just for your understanding, and you don't need to mark all the points if you are asked 3 by 4 and minus 3 by 4. Students, I am sure you must have understood this concept very well. Let us try to plot rational numbers whose numerators are greater than the denominators. Let us plot 7 by 4 and minus 7 by 4. We'll plot 7 by 4 first. Where the numerator is greater than the denominator, in such examples, first we have to convert it into a mixed fraction form. You would have learned this in earlier class, but let me quickly show you the division of 7 by 4. Divide 7 by 4, we get the quotient as 1 and the remainder as 3. So we write the mixed fraction as quotient remainder by divider. This is the whole part and this is the fractional part. So we can write 7 by 4 as 1 3 by 4. Here 1 is called the whole number part and 3 by 4 is called the proper fraction part. Each of the three numbers 1, 3 and 4 tells us something about where 7 by 4 is plotted on the number line. The whole number part tells us the position of 7 by 4. So 1 tells us that the rational number 7 by 4 is between itself and the next whole number. So we know that 7 by 4 is between 1 and 2. So we draw the number line accordingly with just 0, 1 and 2 marked. The denominator of this fraction part tells us the number of equal parts in this segment is divided into. Since it is 4, we divide this segment into 4 parts. Right, students? This segment between 1 and 2 is divided into 4 equal parts. The numerator of the proper fraction tells us the number of parts from the first whole number. So it is 3 parts away from 1. So we mark 7 by 4 here. What about minus 7 by 4? Yes, we can write minus 7 by 4 as minus 1 3 by 4. Since minus 7 by 4 is a negative rational number, so the next number is minus 2. Now we can say that minus 7 by 4 is between minus 1 and minus 2. The denominator tells us the number of equal parts this length is divided into. So we divide it into 4 equal parts by marking 3 lines. The number 3 tells us the number of parts from minus 1. So leaving 3 parts from minus 1, we mark minus 7 by 4. That's it. Here we are done with the topic of plotting positive and negative rational numbers. I am sure you must have understood this topic of plotting positive and negative rational numbers on number line. Kindly practice this concept and make note of the summary which appears at the end of this video. All the best, students.